Hi, this screencast is for AP Chemistry, and it is on changing state. So we're going to look at the different conditions where you change from solid, liquid, and gas, and vice versa. Just to review, solid to liquid is either melting or freezing, liquid to gas is vaporization or condensation, and gas to solid is deposition and sublimation. The majority of students are very comfortable and very good with solid to liquid and liquid to gas conversions. It's a little harder to understand gas to solid and those changes of state. If you are unsure what these look like, please feel free to go look for some resources. I'm sure that there are actual visual examples online that you can pull from. The images I've provided you here are, this one is freezing. Oops, sorry, didn't mean to move it. This one is freezing. The center one would be condensing. And this far right one would be sublimating. You can see sublimation when you have dry ice, when it goes from the solid dry ice to the gas form. Anytime you change state, you are involved with either energy going into the reaction or energy coming out of the reaction. And the energy that you're going to see that goes into the reaction is when you have kinetic energy going in. Now, it is a little bit of a challenge for students to remember that when you freeze, condense, or deposit something, heat is being given off. It's an exothermic reaction. And when you melt, vaporize, or sublimate, it takes energy to go in. A lot of people mess that up. They can't read the graphic right, and they just can't wrap their brain around that freezing gives off heat. Vapor pressure deals with liquids that will evaporate or liquids that don't evaporate. So a liquid that evaporates is a volatile. A non-volatile liquid would be something that does not evaporate. When you evaporate something, you have to have a vapor pressure. And when the boiling point and the vapor pressure equal each other, then the substance can escape the liquid state and become a gas. Normal boiling point is the temperature at 1 atm. Whenever they label something as normal boiling point or normal melting point, they're really referencing that it is at 1 atm, so normal pressure. This is a phase diagram. We have seen these potentially in General Chem, and they offer multiple pieces of information about the solid, liquid, and gas state. You have a triple point here at the center. You have a critical point where the definition between liquid and gas no longer becomes defined. It is now a gas. You will be able to read normal melting and normal boiling based on the normal pressure of 1 atm. You can have a value that exists on the line in between liquid and gas, and if the condition is on that line, then that is a boiling point, or a freezing point if it's between the solid and the liquid. If you have a substance that you're following a particular temperature across the graph, if you're following a particular temperature, up the graph, then you could say that it exists as a gas initially, and then at a specific temperature it becomes a liquid. You can also follow a substance across a graph. One other thing to draw your attention to is the line between a solid and a liquid, and typically the line will point to the right. So if it's a right-leaning substance, then it has one set of density as compared to if it's a left-leaning substance. Water leans left. So in water, is ice more or less dense than the liquid? Ice is less dense, and it's getting hard to read. I'll have to change ink colors. Ice is less dense than it's less dense than its liquid. When a phase diagram includes the left-leaning solid liquid line, it is indicating that it has a less dense solid than liquid. So therefore, the majority of the substances that we experience have a right lean on their phase diagram. So you'll be able to determine about the density that way.